All right, welcome back. I'm super excited to introduce our next speaker, Solange Gueiros, Developer Relations Engineer at Chainlink Labs. She'll be talking about workflows to connect blockchains with the real world. Please welcome Solange.
Hello, everyone. So, let's start it. I think this ETHDenver was so different for me, the way that I'm seeing AI now. Even it was different from conference in the last last year, the end of the last year. And yes, AI is changing the way we build projects and smart contracts. I prefer this. Yeah. And the way we connected blockchain and the external world should change as well. This is my point. This is me, Solange Gueiros, DevRel Education Manager at Chainlink Labs. These are my contacts. Feel free to go to my website. I have presentations over there since 2019 in Portuguese, English, and Spanish. I am Brazilian. This is the presentation. I have some QR codes inside that can be useful for you later. So if you get this QR code, you have everything. 1 minute for you. Yeah. One more. Good. So, blockchain networks are still isolated environments. And we have oracles to connect them with the world. The Chainlink oracles have a lot of resources and a lot of connections to data sources, external resources, like I have here, temperature, my watch, satellite, weather, sports, all the financial information, and real estate. And we do all of this using DONs, decentralized Oracle networks. And this is so important because if you have only one node, only one computer, only one entity grabbing the data outside of the world and bring it to you to use inside your smart contract, this can be compromised because it's only one node doing that. So if you have this using a decentralized Oracle network, you must have some kind of consensus to bring this information to the blockchain. And this is so important because you know that when it's inside the blockchain, it's immutable. So let's take care of this, how you bring the information to the blockchain. But these kind of connections are not so simple. And imagine that. Current financial systems like AML, like a DVP, deliver versus payment, and transfer agents, connecting off-chain data in general, collateral, all of these connecting with public blockchains and private blockchains. This is really not so easy. We need a different way to connect blockchains with the real world. And I'm here to present this for you. Let's start thinking about workflows. And this kind of workflow, a trigger and callback model. You have a trigger, and this will fire something that will be your callback. And normally the callback is some actions and some outputs. This is the Chainlink runtime environment, the CRE. CRE has exactly this, a trigger, and we have the CRE handler that take care of all the run structure, and then the callback. What is each part of this? So what's the trigger? The trigger is when an event that starts a workflow execution. Can be a time schedule, like we call it the cron job, or any on-chain event from smart contracts, or any external API call. After that, we have the callback. Okay, when, and now I have what I should do. This is your business logic, actions and outputs, where you invoke capabilities. And workflow have capabilities. What is this? So, capabilities are the building blocks. I like to think like pieces of Legos that I can combine in the way that I need to my business. Can be a chain reader or a chain writer or an API call to get some information or to save some information outside, any kind of system integration. When I talk about chain reader and writer, this is the interaction with the blockchain itself. And remember that I told before, the CLE render is the glue that connects a single trigger with a single callback. And the CLE handles external data, compliance, cross-chain workflows, and any system integration. How can you use the CLE? How can you create this workflow? You can use the SDKs to write the workflows. You are developing this using Go or TypeScript. These are the languages. It means that it's not that I'm creating only the smart contract on Solidity, but I'm using other program language to do that. And all of this is secured by Chainlink. This is an example in Go for you, how it works. Like I should define what's my trigger, and then I'm calling some function that will be the callback functions with all the steps that I'd like to execute. Important to say that each trigger file starts a fresh and independent and stateless execution of your callback. So they are like closed parts. And remember that in the beginning I talked about DONs, the decentralized Oracle networks. We have this all the time. And we should have consensus in the DONs. And what kind of consensus? How is this? When you think about blockchains, the traditional blockchains, consensus means that we have the validators and they should agree to add the blocks to the state of the chain, to add transactions, to create blocks. But when we talk about the CLE consensus, it's more than this, because it's not only about blockchain. It's about verifying every part of our workflow, like the external data fetching, the API responses that we talked before, the off-chain computation, the reads and writes to blockchains, this is the blockchain part, and any external integration. And we have different ways to have this consensus. We have these aggregation types. We should imagine that we have 5 nodes, and they should be identical to bring the same response. If I do an API call, imagine that I'd like to know a balance of some account in a bank. I have 5 nodes that will call the same API to get that balance in that account. They must have the same result. This is an identical consensus. But if I'd like to get the price of ETH in USD, for example, a data feed, these different nodes can grab this price in different places, like a centralized exchange, a decentralized exchange. You'll be totally different. So we should have a median, like an average volume base, something like that. Also, you could have some kind of consensus aggregation with the beginning, like a common prefix or a common suffix. All of this, you, being a developer, can define when you are creating the consensus in all the parts in your workflow, all the actions, and the outputs. So, every result your workflow receives is verified, not just the on-chain operations. And, okay, come back. Yes. So you can connect any system, any data, any chain, financial systems, public blockchains, private blockchains. And this is the CLE. You can integrate new workflows and capabilities without break existing processes and systems. I think this is a big challenge because blockchain always lives inside the blockchains. And how many systems there are before blockchain and there are outside that we should connect to have more trust? This is a good way to do that. It can accelerate the development, the integration, and time to market for the on-chain applications. And you will build the only ones and run everywhere because you can run this in any public or private blockchain. And this just compose the blocks, build, deploy your application. And some use cases for you, stablecoin issues or tokenization of the RWAs, delivery versus payment, a DVP, on-chain data distribution, or this is so important now, I'm seeing more development on that now, the private and confidential smart contracts and workflows. Here about the confidential compute. This is a hot topic now as well. And this is the link for the CRE, the all-in-one secure orchestration layer. All the resources to you to learn more, to start to use this. The presentation again, because if you didn't get all the links, this is the way that you have all the links. And this is me. Thank you so much.